Hello, everybody, and welcome again on Cafe Dev. For today live streaming, we will see how you can very easily analyze IoT data with time series databases, which are a specific kind of databases that allows you to do this kind of analysis very easily and very efficiently. So let's get started. Hey there, and welcome again on Cafe Dev. So as you may already know, during this month of July, I'm doing a series of live streaming around how to create your first IoT solutions. We already have 3 previous videos around IoT, how to create your IoT solutions with code or with no-code solutions, and also how to do device management at scale. So if you didn't watch this previous video, do not hesitate to go on my YouTube channel, Cafe Dev, to watch them. If you haven't watched them yet, don't worry, this is not a prerequisite for today's module. So if it's your first time on Cafe Dev, welcome, and you should be good to go for now. Another thing, if you have any questions, do not hesitate to send them in the chat window on YouTube, or if you're watching this on Twitter, again, you can also ping me on Twitter and we will try to answer your question live. So today's episode, we will see how to analyze IoT data with a specific kind of databases, Time Series Insights. And I have a special co-host with me today. Let me introduce you to Paul. Hi, Paul.
Hi there, Chris. I'm happy to be here.
I'm happy to having you on Cafe Dev.
It's my pleasure.
So maybe you can introduce you very quickly for people who don't know you yet.
Sure. So my name is Paul DiCarlo, and I am a cloud advocate working on the same team along with Christopher. And we kind of work together in a team called IoT Advocacy, where a lot of our focus is on generating a lot of content designed to hopefully upskill, also inform, and just teach you how to build amazing solutions using Azure IoT services.
Great. So as we saw in the introduction, today we will talk about time series databases and especially one of the services we have in Azure, which is called Time Series Insights, which is a hosted, managed time series database. So let's share my screen. Again, if you want to do all the exercise with us today, you can follow along by going on this address, aka.ms/JulyOT/learn. You can also get this address in the YouTube chat video. And when you go on that, you will have access to Microsoft Learn. If you don't know Microsoft Learn, maybe, Paul, you want to introduce what is Microsoft Learn in a minute?
Yeah, absolutely. So Microsoft Learn is kind of a one-stop online collection of resources designed to teach you how to leverage and use a variety of different services in Azure. Specifically, the ones that we'll be looking at here for the month of JulyOT are, of course, going to focus on Internet of Things types of solutions, but it's not just limited to that. If you are, a beginner interested in learning things like, how to get started with Node.js, perhaps you want to, polish up on some C# skills, or maybe you just want to learn about the latest and greatest ways to do cool things with AI. All of that is available here and is targeted to various different skill levels. So whether you're a beginner, someone that's a little bit more seasoned or even advanced, there's probably something out here that can hopefully teach you something new that you can use to leverage inside of your solution building process.
Yeah. And one of the cool things also of Microsoft Learn is for not all the modules, but for several modules, you can actually do everything directly from your browser. You don't need to install any software. You don't need to have any subscription. It's free. And actually, the module we will go in depth today, which is Explore and Analyze Timestamp Data with Time Series Insights, it's one of these modules. What we will do today together is to actually create an IoT Hub and generating data from simulated devices. So I've been into the details of how doing this on the first video. We will go so quite quickly on this step. And actually we will create a simulated device coded in C# directly in the browser. So even if you don't have any .NET SDK, or I would say even if you don't have any .NET skills, you can follow along and actually generate simulated data from your browser. And then we'll go ahead and create a time series instance and connect it to the IoT Hub to actually get all this data into the database. And we will see how we can use Hadoop queries to gain insights from this database. Should we get started?
Let's do it.
Great. So a quick introduction around why this topic could be important if you're creating your first IoT solutions. The fact is the Internet of Things type of devices can generate a massive amount of data to analyze. I read an article earlier today saying that a connected car could generate as much as 4 terabytes of data per day of usage. So it's one of the small sample where if you see a car, you cannot imagine having such a large amount of data for only one car. And imagine you're actually a car making company and having millions of cars on the roads. If you have to analyze all this data, it's definitely a massive task to tackle. So yeah. Basically, when you get all this data to analyze, you need to find a way to get this data from the IoT devices, and Iot Hub is helping you to do that. And then you need to store in a kind of database all this data. So Paul, when you see this, if I task you to actually create a data store for storing all this data from connected car, for example, what would be your first pick?
Well, one of the things that I really like about Time Series Insights, which we'll look at today, is the fact that it is able to organize and make sense statistically based on data that's coming, or signals that are coming off of sensors on whatever the device happens to be. So what becomes kind of interesting here is that when you're looking at things over time, for example, if you wanted to do something like determine where was the vehicle over time, or perhaps even want to look at things like what's the health of the engine by looking at vibration sensors and things like that. Analysis tools like Time Series Insights become really important because they can essentially look at those and do statistical analysis over time. But the important thing to think about is how do you even get that data in the first place? And I think the easiest way to go from sensor to cloud, where you could then leverage a service like this, would be using something like an IoT Hub.
Yeah, definitely. If you remember, for those of you who already watched one of my previous videos, basically we have sensor embedded in some IoT devices, and to connect to the cloud, we use a component called the Iot App, which is basically a gateway for your data from the devices to backend services. And backend services could be your own code, but it could be some of the other services like time series instance. And we will see during the module that you can actually very easily connect the IoT Hub to the time series instances. So doing the ingestion process is actually very easy with Time Series Insights. It is a matter of configuration, that's it. So yeah, definitely the first step is how to get your actual data from the IoT sensors to an operational database, and this is included in Time Series Insights. So one of the other things people may come up is why we don't just use a good old SQL database for storing this data, because we already know how to use it. It's usually there in a lot of different applications. So why we don't use a SQL database? And there is two part of the answer to this. The first thing is actually scale. Oops, sorry for my white wings. Scale. One of the issue again when you're doing this kind of massive amount of data is how you can ingest, like for example, 10 gigabytes of data per let's say minute. If you have this kind of scale, it's very difficult to use a relational database to actually store all this data. Usually, the SQL databases are optimized for different type of workloads, including insert and update. But when you're thinking about time series data, actually the process is a little bit different, because if you look at sensor data, what's happening is basically you're adding at certain point of time a series of data metrics from different sensors, let's say temperature, pressure, and humidity maybe, and voltage, and other kind of data, and this is input at a specific time. And the next operation, actually, when you've inserted this kind of data, you are not making any change to historical data. So it's basically insert only. You can request, do a query over your data, of course. We will see that you need to manage deletion of old data, but actually you're not modifying any data. And after a while, or maybe after a few milliseconds, you will insert a new set of metrics within your time series, and we go over and over doing things for maybe a long period of time, over years of historical data, or maybe with a huge input throughput, and these kind of behaviors do not scale well when you're using a SQL data. The second reason we are not choosing actually a SQL data to do this kind of works, and Paul, you started to mention this, is actually how to make all this data usable. So how we can query these data in an easy way, and doing some statistical analysis over time. So for example, what's average temperature of the last hour compared to last hour 5 days ago. That's something you want to do if you want, for example, in a factory that is not working on a weekend. Obviously, you cannot on Monday compare to an average temperature to yesterday, because yesterday was Sunday and the factory was closed. So you will have a difference in your sensor data. But if you compare to the last Friday, or the last Monday, sorry, then you can maybe detect if something is wrong. So you need to find a way to actually being able to query the data, and to do things like comparing things, calculating anomalies over a period of time. And if you're going to do this kind of scenarios, then you should think about the time series database. The ways time series database is configured and created, and the way they store the data actually gives you the ability to do this on a very high scale and very efficiently. We're talking about querying years of data in under a second for the execution time of the query. So that's basically,
So what
yeah,
are some
sure.
of the sorry Chris, before we jump on, what are some of the canonical examples, I guess, of using this type of a service? You know, what type of solutions require or produce time series type of data?
So actually,
You'd mentioned
yeah.
manufacturing, and I'm just curious, yeah, what else is
So
out there?
actually, it's not related to IoT, but one of the origins of time series databases was for financial markets applications, because you know that financial markets are moving very fast. There is a lot of operation happening in the second, and the price of an action can be modified in a second very intensely. So we created time series databases mostly for financial market applications at the beginning. But right now we have a lot of different application in the farming industry. We are doing more and more things around IoT in the farming industries, and we need to again watch out for a lot of different sensors data, or even if the data is not coming from a physical sensor per se. So maybe it's I don't know. You're actually weighting a cow, and you're inputting that the weight of a cow in an application that's kind of time data. Some time series databases that do not have a large volume of ingress, but still can be analyzed in a time series. So manufacturing, all connected vehicles are also a huge source of data. It could be airplanes, it could be engines on the airplanes, it could be cars, obviously, rockets, etc. It's also a huge space where we see time series databases.
Very cool.
So, as I said, there is actually, I need to say more that there is few open source time series databases. The concept I've just shown, and some of the concept I will show you in Time Series Insights, also applies to some of the open source time series databases. But the difference, one of the main differences between open source things and a service like Time Series Insights is Time Series Insights is managed service. So basically, you just have to create the instance, and you don't worry about storage, replication, high availability, etc. So if you're just getting started on this area, or if you're just a developer and you do not have any knowledge about how to scale these kind of databases, Time Series Insights is a great service, because basically you can focus on your application and your data and do not worry about the underlying infrastructure. And that's one of the cool things I like about Time Series Insights. So to go over this module, actually, as I said, you do not need anything, just in the browser if you want to follow along. And again, do not hesitate to ask some question. I have a question from Shane. Which vendor cater to time series databases? So which other time series databases are out there? I will input at the end of the stream some of the other interesting links around this if you're curious. So what we do today is we will create an asset tracking system for cheese. As you know, I'm French, and we have a huge number of different cheese in French. And the idea is when we are moving. When we are shipping cheese, basically we need to ensure that there is specific conditions, so the cheese is still at its best when it's delivered. So we will try to mimic an asset condition tracking system. So let's get started with the first module. So I'm using here a sandbox, which means that basically, even if I already have an Azure subscription, obviously as a Microsoft employee, I'm actually using a Microsoft Learn subscription, so I don't have to pay anything. I don't have to ask any access to anybody. So the only thing you need to have is a Microsoft account, and then you can logged in on Microsoft Learn and actually request a sandbox. And in a minute, I will have there on the right of my screen an Azure Cloud Shell. So I will be able to type in some commands to create some resources. So what we will do in this first unit, I will go very quickly on this unit because I've spent a lot of time explaining what's happening there in my first video. So what we do there when the module is loaded is I will basically use the Azure IoT CLI extension to create a few things. The first thing I will create is an Azure IoT Hub. So it's basically a gateway that will help me communicate messages and sensor data from my simulator to Time Series Insights. And then I will create 3 fake devices, and then I will get the connection information for these 3 devices, so I can use that connections within my simulator program. So I will start. Let me take my keyboard. I will start by giving a name to my IoT Hub. Chris JulyOT. This one should be available. Let's see. So this. Oh yes, sorry, I didn't run the first command. My fault. I went too quick. So yeah, basically, when you install the Azure CLI, you can already do a lot of things on like the main Azure services, but the IoT Hub range of services is actually quite complex, and there is a lot of commands around that. So you actually need to install an extension to the CLI. And it seems no, I've already created that one later on. Let's see, IoT name 02 and create the IoT Hub. So it takes a few seconds to actually create an IoT Hub, but actually behind the scenes, it creates a lot of different components. So it's very quick for what's done behind the scene. And we will see later on how you can do it from the Azure portal, at least how you can get access to your IoT Hub from the Azure portal. Yeah, one other thing I wanted to mention why this IoT Hub is created is you saw I've input a name Chris JulyOT 02. Actually, this name will be public in a sense that this name is part of the address, the URL of the applications. So do not put any secret name there because somebody may be able to see it. So when the Azure IoT Hub will be created, we will create a device identity. So basically, the IoT Hub has several features. One of them is actually exchanging messages between devices and cloud applications. And the other big part of the IoT Hub is actually a device database. So when you want to connect a new device onto IoT Hub, you need to create it first on the IoT Hub device database, and then you get connection informations to actually connect this device to the IoT Hub. And you can do a bunch of different things. And again, watch out my first and third video around device management to see all the good things you can do with Azure IoT Hub. And then the next step we will need to follow is to get the connection string. So basically, when you want to connect an IoT Hub, a device to an IoT Hub, you have several ways of doing this. The first one is basically using a connection string. Paul, while I am creating the device identities, would you mention the other ways we can actually connect a device to Iot Hub?
Yeah, so the kind of easiest way to go forth with a secure connection from device to cloud is, as you're showing here, the connection string. But there's also ways to do things using our device provisioning service that can allow you to connect a device in a very automated fashion, which is kind of cool if you think about potentially manufacturing a number of different IoT devices that perhaps leverage Azure IoT services in the back end, and you want those to go, from time of manufacture to maybe something that you can pull off of a shelf, open the box, connect it to the internet, and have it register itself at that point in time. We do have mechanisms for that. Falls under our DPS, or device provisioning service. And it is another secure way to do that, but also enables you to unlock those types of consumer experiences that you would, sort of see from, you go there, you pick the device up, you come home, you set it up. And it's really fantastic how that works. It can, take into account where your geography is. And perhaps if your solution uses multiple IoT hubs in multiple different geographic regions, it can actually do things like look at the latency that it takes to speak to all known IoT hubs, and it will go ahead and register itself with the one that has the lowest latency. So not only does it give you that secure, automated way of registering, but it can also optimize that connection so that your device is ultimately achieving the fastest path from the device to the cloud that's possible.
Yeah, definitely. So while you were talking, the Iot Hub has been created, and I've went ahead and actually create the device identities. And the next step is I jump into the next step, which is actually creating our device simulator. So for doing this, I'm creating there a very simple .NET Core CLI application. So I'm creating a directory for this and using the .NET new console command to actually create an application, and adding a few packages that allows me to easily connect my C# program to an Iot app. But obviously, if you're not using C#, you can definitely connect your software to Iot app. We have a C SDK, we have a Python SDK. I think we also have a JavaScript SDK. So we have a ton of different SDKs, and if we do not provide an SDK for your specific language, you need to know that Iot Hub can work with open source protocols like MQTT or HTTPS. So basically, any kind of devices that can connect to an internet endpoint should be able to communicate with Iot Hub. So yeah, I've treated my project. It's empty for now, and I've also redo the commands to show the device identity. So this is actually a very secret thing. I should not be showing you live, but fortunately it's from a sandbox, and I will destroy these things. But actually, if somebody has access to this specific line of code, they can send data on behalf of your device. So if you're not using service like DPS, like you mentioned, Paul, be very, very cautious about who has access to these shared access keys. So I will go ahead and update my program.cs. So one of the cool things of the Azure Cloud Shell is you can actually have a very lightweight but an embedded code editor within the Azure code itself, and so within Microsoft Learn itself. So again, if you have nothing installed on your PC or Mac, no worries, you can actually execute this module. I will not go over into details about this code. It's very easy, and there is a lot of commands within the code, but basically what this code will do is it will create fake sensor telemetry data from 3 different devices, and you can see these 3 different devices at the top. One is the truck, the other one is the airplane, and the last one is a container. So the idea is for shipping our cheese, we will ship a container, and we will have sensor within the container, and during the transport, during the journey, this container will go from a truck to an airplane and back to a truck, and we want to correlate data from the truck and from the container. And so maybe we'll be able to understand only from this data at specific point in time if the container was on a truck or was on an airplane by correlating the sensor data from these two different devices. So to actually run the simulator, I will need to replace this line of codes with the actual connection strings. So I will go ahead and do it. And after this, we will run this program for a few minutes so we can generate some interesting data. So there, and the last one.
And I suppose one of the other interesting takeaways here from this code is it's a nice example on how to use those SDKs, specifically in the realm of .NET, which is cool because you could theoretically run this wherever .NET Core runs. So this could technically run on a Raspberry Pi or any other device essentially that's capable of running the .NET runtime.
Yeah, definitely. And even I saw the .NET Nano framework, which is kind of an extension of the old micro framework that can actually run directly on an embedded system. So yeah, with .NET Core, you can actually run this on a very wide range of devices.
So you could go down to a microcontroller, not just a microcomputer. That's interesting.
Yeah. So I've started my simulator, and as you can see, it's sending some data with some temperature and humidity, and I will not directly click on continue there because I want my simulator to run in the background. So actually, I will right click and open the next unit in a new tab. Okay, and I will leave this running for a moment. So I encourage you to actually do the same if you're doing the module. The other way of doing this is to let this run for something like 1 hour and go back to the module. But you need to be aware that there is a time limit. There is plenty of time, but if you forget or do something else, you may come back and do not have sufficient remaining time to actually complete the module. So doing 2 tabs could be a clever trick. So let's get onto the Time Series Insights part. So for this, we will go on the Azure portal for the sandbox. So please use that link. Do not go directly on portal.azure.com because it's a special link to open the sandbox subscription. And I will have to log in, so I will remove my screen for a second. And I'm back. And what I will do is I will do side by side the tutorial and the Azure portal. Yeah, here we go. So we will create a new Time Series Insights instance. So for doing this, you can go on Create Resource, type Time Series Insights, and click on Create. Be sure to select the Concierge subscription, so you're actually using the Microsoft Learn Sandbox subscription and you're not paying for anything. And resource group, you should have only one resource group, so that's kind of easy to pick up. I will type an environment name, Chris JulyOT 02, and then you have a location. So you have a bunch of different locations. I will pick West Europe because I created my Iot Hub on West Europe. So I'm getting the data from the local Iot Hub. You need to understand where your Iot Hub is located, or if you are using several Iot Hubs, how your solution is architectured to pick up the best location. But basically, if you're doing a simple project, just choose only one location for all your services, and as long as you're on the same location for all your services, you should be good. And then,
That also
yeah,
extends because they're in the same data center. Essentially, you reduce costs because there's no egress charge to go from, say, West Europe to the U.S. had you chosen West U.S. And so because of that, it's actually a little cheaper if you are mindful of where you keep your resources.
absolutely. And then you have to select a tier. So basically, what you need to know is there is two generation of time series insight. We just went in a GA, general reliability, for generation 2 of time series insights. So for, I think for most of the new projects, you should pick up Gen 2. And Gen 1 has less possibilities and also less retention period, while Generation 2 you can have unlimited retention, because basically you will see that in a minute, but with Generation 2 we can actually store the data into two different stores to optimize your usage and consumption, and also pricing and performance. So I highly recommend you to pick up Gen 2 there. Then there is one of the things that is really, really important, which is the time series ID. So for this specific demo, you will need to pick up this, the IoT Hub connection device ID. But maybe we can spend a bit of time digging a bit about how all these things are working. Paul, do you have any insight about what is a partition key, maybe generally speaking?
Yes. So this is probably the most important field when you are launching the TSI service, and there's a number of reasons why. So what that field is, it's essentially a partition key because this is going to go into a essentially a NoSQL database. So it is non-relational, and by having that partition key, it allows you to very easily create queries that are optimized in terms of the data that can be returned from your results. So if you think of partition keys, which is also an option, you could do something like have a sensor ID or say a sensor location in addition to an IoT connection ID. And that allows that partitioning allows that data to be a lot more easily and quickly retrieved from the NoSQL data store. And I can see here you've got a little bit of a drawing here that I think will help explain that a little, how that works under the hood.
Yeah, definitely. So basically, one of the keys to any database scaling is being able to partition your data, because if you want to partition on a massive scale, you will actually need to scale onto multiple servers. So here I have server 1, for example, server 1, and you see here S2 and then S3, and you can go up to a lot of different servers. But actually, if you're doing this, you need to understand when you have a new data that is incoming from your service, where should you put that data, on which server, because you cannot just randomly store your data anywhere on any server, because at the time you want to query that data, you will actually need to know which server to tap into to get your data. So actually choosing the partition key, and I think it's mentioned on this. Yes, it is important that you specify the appropriate time series ID during environment creation, since you cannot change it later. Why you cannot change it later? Because actually this partition key will actually change the way your data is stored and slice physically onto the file systems and onto the servers. So obviously you cannot change it later, because you will have to remove all your data in a different way. So that's something very important. And actually, if I go back to my drawing there, each of the metrics will actually be stored in a kind of a different table. So each one of these will have its own table and actually all the sensors. So maybe this data is from sensor 1, that one is from sensor 2, etc. Each of these data points will be stored differently, like maybe one file. I'm doing like a very schematic, it's not exactly the way it's stored within Time Series Insights, but actually all the sensors, so if that data is from the sensor 1 and that one is from sensor 2, at the end you will have on the file system basically temp folder, and then you will have s1 dot that and s2 that is a very schematic way of representing what's happening behind the scenes, but the fact is you will not have one file for all the temperatures. All the data from all the temperatures will be divided by the partition key. And that allows us to basically scale to very large number of devices and to actually get a huge input throughput, because we can at the same time we can store the data from a lot of different sensors without having to do any lockings on the table or that kind of things we usually see on a traditional relational databases world. One of the other aspects of TSI we're discovering during this creation wizard is the concept of cold stores. The concepts of cold store and warm store. So basically, one of the cool things of Time Series Insight is it will give you two ways of actually storing your data. The first one is simply using an Azure storage to store all your data. It's a default way of storing things on Time Series Insight. So as long as you're creating a Time Series Insight environment, you will need to actually have a cold store. So let's type name Chris. What's the name? Store Chris JulyOT. You can replicate the data if you need to have some durability requirements. If you think about using this with other Azure services like HD Insights, you can actually create a data lake storage namespace for this as well. So basically with Time Series Insight, you can store almost as many data as you want, unless you reach the limit of the Azure storage accounts, which are very, very big. So we can have maybe 10 years or 20 years of historical data stored into Time Series Insights. However, when you're doing some queries, you will end up actually doing a lot of transactions on this storage account itself. And you may not know it, but in the Azure storage account, you're paying for two things. You're paying for the amount of data you're storing, but also for all the transactions. So if you're using this for example, displaying a live dashboard, you actually may end up having a kind of a huge invoice just because you're querying your data, I don't know, every 5 seconds to refresh the dashboard. And that's why we have another options you can enable if you want, which is a warm store, which is basically we will Time Series Insight will duplicate your data also on a warm store that is entirely managed, and the only thing you have to input is the data retention time. So how long you want to store your data in this warm store, and if you're doing this, you will actually get very high query performance, but also unlimited queries without having to pay for an extra per query. So that's a great way, because a lot of IoT data we're manipulating, we are actually interested in, I don't know, the last 24 hours of data, or maybe the last 2 weeks of data. And the other one, we want to have access to them if something happens. But on a daily basis, you don't require a lot of historical queries. So enabling the warm store gives you the best of both worlds. And again, everything is managed.
What's the highest data retention time there, just out of curiosity?
So you can go from 7 to, I think, 31 days.
Okay.
So once
and that's and those are the high queryable data. So essentially a month's worth of data you can obtain with that higher performance feature. That's cool.
Correct. The next thing we need to set up is the event source. So which is basically how I get the data from somewhere to inside Time Series Insights. And one of the cool things is data ingestion is actually one of the features of Time Series Insights. So you don't have to create a program or, I don't know, Windows service somewhere, but we actually collect the data from the IoT Hub and send them, insert them into the Time Series Insight. Time Series Insight, we take care of this feature for you. So you can, at creation time, you can create a new event source. As you can see, there is two types of sources, the IoT Hub and the Event Hub. That means is not really the topic of today's, but that means that if you have a custom business application that generates time-based data, you can also use it. You can also use Time Series Insight for this. Time Series Insight is not limited to IoT devices generated data, but we will pick up IoT Hub for now, and I would say hub data source. I will pick up my IoT Hub name. I will need to access. I will need to pick up an IoT Hub access policy. For this, I will select the IoT Hub owner, which is basically the root, the admin access to IoT Hub, but you may want to create a specific access policy limited to TSI. And then another interesting thing is the consumer group. While I'm creating a new one, Paul, do you want to explain very quickly what is a consumer group within IoT Hub?
Sure. So while the IoT Hub sort of sits as the ingestion point for all of your IoT devices, when devices want to query that data or consume that data, I should say, you essentially want to set this up in a way where your applications are doing that on a per application basis. And so the consumer group allows you to access that data in an independent fashion, meaning your Time Series Insights instance is going to use that Time Series consumer group to set essentially a start position from when the last time it consumed that data, where it knows we're in that full stream of millions of events that are coming into the IoT Hub, where it last got that data. Now, where you get problems with this is if you're trying to create multiple solutions in the cloud and you start reusing the same consumer group, one of those applications might move that key point where you currently are, or that index where you are currently looking at data from the IoT Hub, and they would then become out of sync, essentially, where you'd have two apps where one's looking at data over here, but this one wants data from over here, and they sort of skip each other. So the general best practice here is that per app, you would want to create a consumer key, and that allows them to independently consume data from that IoT Hub and ensure that they never miss a single result or entry from that telemetry throughput channel.
So that's why here I've created a new consumer group, explicitly named Time Series Consumer Group, so I know that this specific consumer group is for my Time Series environment. And the last bit of information is the timestamp property name. The fact is you can actually, if you have specific requirements around which timestamp you used to map your event to a timeline, you can actually specify which property within your event should be used as a timestamp. So for this, I will not input any property name. I will just use the message and queue time as a timestamp for this event. But depending on how you're generating and sending your events to TSI, you may want to change that. So I will go ahead and review and create. I should be good to go. And yeah, and I will create the environment. It will take a minute to create. So let's jump into the next step, which is actually analyzing, accessing all this data from the Time Series Insights Explorer. While this is creating, let's see how to do it. So actually, when you're in the Azure portal, you can search for Time Series Insights environments, and you will have access when you click there. You will have access to all your environments, and have access to some admin functions for giving rights to other people, because one of the cool things, we will see this in a minute, is you can actually share the Time Series Insight within your organization. So you can invite a lot of different users to actually access the data from the Time Series Insights. And you have like the events rules you can configure, and a few other things. But almost everything is happening into a specific page, which is the Time Series Insights Explorer, which is like an end user interface to actually accessing and querying data from your Time Series Insights environment. So we will see this in a minute. One of the things I wanted to show you very quickly is you can do cool things like that one. I really like that one, which is comparing like as you can see there in this screenshot, I've actually have two line charts, and it's from the same device, from the same sensor, but there is a time shift applied. So which means that this the second one, the second line in a light pink, is actually the data from the sensor 30 minutes earlier, and you can do like a day earlier or that kind of things, and you will see when we have the environment created that you can actually do this very quickly. So my environment is created. As I told you, you can here on data access policies share your environment with other person in your organization. You can add other event sources if you want, but everything is happening into this TSI Explorer. So I will go ahead and click there and get connected to my Time Series Explorer. It takes a minute to load. And here we are in the TSI Explorer. So as you can see, I've already had like 21 minutes worth of data, because I still have there my my little simulator running in the background, and actually TSI gets all this data, even if I've started to send messages to the Iot App before the creation of Time Series Insights. So I can click there on my container device and try to add the humidity and temperature graphs. So I can get two graphs and then see all my data, and I can do a pretty cool thing. So for example, there my temperature is lowering, and I can, as you can see, select a specific zone and click on zoom, and I have like an instant results with my data. So you can actually move and get sub-second updates of your graphic, even if you have a huge ton of data. So that's one of the cool things. The other cool things you have in this is the explore events. So you can have access to actually the underlying data that has been ingested by Time Series Insight, and you can even download it as a CSV. For example, if you need to do some kind of reports, but you can do more. You can, for example, connect to a Power BI. So if you have a specific analysis to do and you want to share it more broadly and with some tooling or to correlate the data with, I don't know, the shipping data, like which customer is getting this specific shipment, you can do this kind of analysis on the Power BI. As you can see there, I have the warm store queries enabled. So there is a yellow box underlying there. This is a warm query window. So because I've choose 7 days of data retention on the warm queries, all my queries I can do today will be under the warm store queries. But if I let this demo running for months, obviously at the end there, I will not have this yellow box, which means that doing any queries on historical data will be made on the cold storage. Paul, do you think there is one other thing we need to show on Time Series Insights there?
One other thing I'd look at is we're bringing in data that's, I guess, really easy to, by default, graph and view onto the Time Series Insights interface, but also over on the left, they're modeling. So depending on what the shape of your data looks like, you can actually come into here and define essentially a custom type. So perhaps you've already got a legacy system that's producing some sort of formatted payload. If you're able to get that into your IoT Hub, you can then create a special type that will allow you to essentially render that in a specific fashion. And the type modeling system is actually really advanced. You don't just specify fields, you can also specify special queries and things like that to sort of zero in on things. Like, if you want only values, where the maximum is equal to something, you can do all sorts of ways to slice that using aggregate methods, as you can sort of see there. And it depends on what it is. The TSI environment is smart to know if your data is already coming in as a numeric value. It'll sort of give you some hints on how to do that. Similarly, the hierarchies section is interesting because the way that Chris's data is currently presented in the TSI window is by the IoT Hub connection ID. But if we wanted to instead maybe do this by like building ID or location, you can create this concept of a hierarchy that will essentially allow you to do a logical grouping of any of your data, any of the data producers that are using that time series partition ID. And from that, you can start to look at these in a little bit more easy to consume fashion. So here's a great example of that hierarchy in action after Chris has created one, where you can sort of go down into, look at the whole plant and then say, in each of these different rooms or whatever these may be, these sections, here's the different sensors that are available in there. Allows you to get a really nice command and control and customization. Which the big takeaway there is that TSI is one of those services that's really data reliant. If you're able to get the data inside of it, it then becomes the job essentially of the time series engineer or whoever ends up building the system out. As long as they can model the data appropriately, you can then start to visualize it and then take advantage of all the features, for example, the sharing, the exporting, the tagging, the time sliding, all of those sort of things become accessible to you. And it's really just a matter of getting your data in and modeling it appropriately.
Yeah, and I don't know if you see this, but I'm actually requesting more than a year, like 1.5 years of data, and it actually took like less than 3 seconds, I think, to show me all these informations. So as we saw, we can actually dig into a lot of different data, historical data, very, very easily. Before we wrap up, I wanted to also show you a few interesting things, because obviously you have these great Time Series Insight Explorer, but maybe you want to actually use Time Series Insights just as a database and actually plugged into your own UI. And this is something you can do. We have C# SDK, for example, for getting this. But if you want to have a mix between the Time Series Explorer experience within your application, you can also use the Time Series Insights JavaScript SDK. So you can go on, I will actually copy paste that link on the chat window. You can access the GitHub for getting all the code behind these samples. And I just wanted to show you two quick samples. The first one is one from a factory where you can basically have a ton of different information. This is information from sensors, and this is some events happening within the factory, and in the last part is the states, different states of different devices all in one graph, and you can have this UI control within your application, but you can also create live operational dashboards. So this is another demo where you can actually see a temperature and a pressure updating live based on the warm store of Time Series Insights. So every second I get the latest updates, and I'm only using the warm store to actually get the temperature and the pressure data. So that's few cool things you can do with Time Series Insights if you go beyond the Time Series Explorer and you want to actually use it much more like a database, but an end-to-end product. So cool. I don't see any question on YouTube. I'm trying to see if we have any questions on Twitter, but I don't see any of them. So with that, I think we can wrap up this fourth streaming. We will catch you next week for our last episode, and for this last episode we will talk about how to use AI at the edge. And Paul, I think you will join me again next week, and you have cool things to share with all of us, right?
Absolutely, yes. And this is a topic I'm obviously very passionate about. So would love to see you folks out there join us again for that one. It's going to be more learning, more fun, and some exciting stuff. And a great way to just kind of end cap all this content that we've created. It's been fantastic this entire month for JulyOT. We've pushed out unique themed content every single week. And I think this is a great way to sort of end cap it. I know right now we're focused on producing a bunch of content around certifications and learning resources and things like that. And this is one of those learning resources. But additionally, if you have been tuning into this series and perhaps you wanted to take this and turn it into an official designation, there's opportunities for that. In fact, if you head to JulyOT.com, you can see all of the work and projects we've been doing. That includes all of Chris's live streams, in addition to other resources and projects if IoT happens to be an interest of yours.
Great. I've just copy pasted the link to JulyOT in the chat window, so do not hesitate to check out this website to get access to all the other content we are doing during this month. Paul, thanks for being with me for today's live show, and I will catch you and all the other viewers next week, same time, to talk about IoT at the edge. See you soon. Bye-bye.